Hi, everyone. Thanks very much for coming today. I just really thank you very much for coming to the robotics event tonight. This is our regular gathering. We do it every month. My name is Tim Trahan. I'm the host for today. We also have several other organizers that are with us as part of robotics. Mike Sudano and also Nick. He's also going to be coming later today too. But today I have a really exciting program for you to talk about robotics. And then afterwards, we're going to do some networking as well. So thanks very much for coming. The first program we have today is an introduction to Syngenta Group, led here by Taiki. Thanks very much for coming. And I wanted to give you a brief introduction to Taiki. He's had quite a bit of experience in the robotics and also industrial areas, working at Mitsubishi. And then most recently at Syngenta. Am I saying the name of the company right? Okay, thank goodness. I was a little bit worried. So I'd like to invite you to just say some words and introduce your company and yourself as well too.
Okay, so it looks like no one else is still on the way to here, so probably I'll try to kill time, yeah? So my name is Taiki Fukunaga, and currently I'm with the Syngenta, which is a Swiss company, mainly focusing on the agrochemical areas. So we basically produce the pesticide, and also the seed is another business lines. And then this company has been formed back in the 2000s. So we have like a 20 some years history, but previously we are part of some pharmaceutical companies like Novartis Pharma or AstraZeneca or maybe many other like agrochemical companies are our forefathers. So it's one of the biggest player, mainly focusing on the agri sector. And then our key focus is, used to be, it's manufacturing and distribution of the chemical products, but it's no longer firstly, especially in Europe, it's no more the sustainable or promising business there. Lots of the restrictions. And also people are more concerned about the food security in every corner, as well as for instance, how to reduce the impact to the environment through these farming activities. Because actually the carbon emission, agriculture is one of the biggest cause of this carbon emissions. And also because chemical products are essentially not so safe in a sense, right? It can harm some natural habitats and so on. So we are also thinking about how we reduce the use of the herbicide or pesticide, which is our main product, of course, right? Which means we are like squeezing our futures. Instead, we are also looking at many different ways, especially when we are talking about the protection of our crops. It can be anything, right? You don't have to spray, but you can apply the robots, for instance, autonomous robot, who can monitor it. And nowadays we have plenty of this, the startup companies offering many solutions. And the Syngenta itself is still having some internal project, but we are most likely to collaborate with many external parties. So for instance, one of the most advanced solution nowadays is like valuable applications. Valuable means, you don't have, historically we spray, evenly to all the fields. But now we have the technology to define which area needs more treatment and which areas are not. Right? By using, for instance, a satellite imagery or a drone image or maybe the field sensing, then we apply minimum necessary amount of the like a chemical instance or whatever to the plant or to the soil. So that's really, really impacting this reduction of the environmental impact. We are also talking about the let's say like a productivity improvement for the farmers. Right? Farming activity is historically very like a labor-intensive activities. But because we are seeing huge like a decrease of the farming populations. For instance, in Japan, 10 years ago, we had more than 2 million population who were engaged in farming activities. Now we only have 1.1 million. Only in 10 years, it's nearly half of the size. And we are also expecting a radical decrease in next 5 to 10 years because you see, if you see the demographic of these farming populations, 70% of the people are already older than 55 years old, right? In next 10 years, many of them will retire, and only the people left behind is it's like a 20% of the current population, which means like we will probably have 200 million, 200,000 people who are engaged in the farming. But we still have this arable farming land. And how do we, let's say, explosively increase the productivity? Like it's not like the 2 times, 3 times, it has to be 10 times more. And it's only be possible by applying some automations, yeah, based on the data, using the AIs, and actualization is the biggest part because farming activity is a physical task. So without having robots, how do we do it? Yeah, with the less hands? This is always the biggest challenge here. And Japan is not the exception. If you look at many other countries like Europe, US, those forefront of those agri innovation, they're also seeing the same situation. And in Asia or Africa, still we have a huge population there, but they will eventually see the same problem. Because younger people are no longer interested in just the physical work or something to do with soil management and so on, right? As you see, people here, probably the younger generations are more to the keyboard or typing and also the coding. That's their job, right? So, but we also would like to invite those people, tech generations, to the field. So that's where we are. So thank you.
Thanks very much for that. I appreciate it. I was wondering if you could share a little bit of knowledge about any of the kind of advancements in the robotics used in agriculture for Japan. Have you heard anything about these things?
Yeah, because in Japan we have some leading farming machinery companies, right? Like Kubota, Yama, or I think Iseki. Those are the 3 major ones. And we also have a famous construction company called Komatsu, right? All those companies are now focusing on building the autonomous machines, right? Or remotely controlled machines. And especially when you talk about this Komatsu company, they are famous for construction and mining machines. Their machines are fully equipped with this, the IoT devices, sensing, and also they can remotely manage. So nowadays, they don't have to send the service mechanics to the field, but they can always detect any sign of the wrong behavior of the machines, and they can instantly send the replacement part to the on site. So they can fix everything in advance to any problem happens on the operations. And also nowadays, for instance, if you go to Australia, huge mining mountains zone, the trucks are just driving autonomously. No one is touching anything, right? And also nowadays, this remote controlling technology is also evolving. So it's not yet happening in agriculture, but eventually we'll see. Like one person handling 10, 20 of the farming machines, on a room just in front of the screen, and machines are doing something on the field. Also, the key challenge in agriculture is the soil and the plants and the land is not it's the same, right? It's always some variances, and you can just simply automate, but you also need to apply additional observation of the. Nowadays it's the humans, but if we could apply more of this imagery analysis and also the AI technologies, maybe there could be a day where we can fully automate those machineries in the end. Also, humanoid is probably another area we should consider, right? But I'm not sure. You see the Teslas and the humanoid robots. Maybe in some cases, those humanoid robots can replace the people in the field in the future.
Thank you very much. That sounds really inspiring, especially the fact that you've seen these kinds of advancements coming out and seen some examples. I understand it may not be completely saturating the market here in Japan or other places quite so much, but I was wondering, more broadly, in general, is there any way that this kind of automation or the software side of things has really impacted Sagenta's business in terms of your market here or other places in the world?
Well, it can impact because, as I said, for instance, weed management is one of the key, critical tasks for the farming activities, right? Traditionally, the people were picking up the weed, right? Then in modern days, we just spray the herbicide. But many countries are now, banning those use of the herbicide. Yeah? Famous one is, of course, those Monsanto things. And so that's some robotics startups are now trying to offer those autonomous weeding machines. They just run through these fields. They detect by the camera sensors and just wipe out all the weeds and so on, right? And this will drastically reduce the use of the herbicide, which means a huge threat for us, right? Because we are losing the ground. But is it okay to just sit down? Or is it okay to lobby to the government that the use of the robot on the field can be unlawful thing? Maybe not, right? So we are more like a progressive here, right? So we are trying to invite those robotics startups to join us, and we'll put them as a part of our service solutions. Also, product out style of the business for the manufacturer is older style, right? Nowadays, many things are moving to the like a subscription base. So why don't we just go out to the field, talk to the farmers, and just contract with them for like an annual field management service. And how do we do is up to us, right? So we can either use the spraying some chemicals, or we can also send out the robots to do all the jobs. So that in the future, farmers are just a landlord. They are no longer the real farmers, but they just sit in the home and they just pay for, subscribe for some additional service, and everything will be done by someone or robot. So that's how we see the future as in our core business.
That sounds like quite a change from the family farm.
Yeah.
Okay. Well, I was also wondering as well too, is there any specific places that we can go to see examples or demonstrations or research done around these kind of robotics?
Yeah, sure. In Japan, the most notable changes or use case is the use of the drones, right? And the drones are now becoming more autonomous. So in some years back, we only have remote control drones. But now many drones are fully autonomous. So you can just fly them once. They will just detect, for instance, the boundary of the field plot. And they also plan all the like a flying paths and so on. And they also correct some, for instance, satellite sensing data to understand where to be treated. So drone will just fly, and they will spray the necessary amount of fertilizer or herbicide or pesticide in the place where it needed. And this is already widely used in many locations in Japan, especially for the rice and maybe for some soys and wheats. Right? So if you go to, I don't know, maybe larger farming areas like in Niigata or in Saitama or even in the Hokkaidos, you can easily find those places too.
So already we're having drones that are delivering fertilizer, pesticides
Yeah.
to, I guess that would be like the fields
Yeah.
where they're growing rice
Right,
and other
right.
kinds of produce and things
Sure.
like this.
Yeah.
Okay.
Right.
And that's all across Japan right now.
Yeah, it's can happening already.
That's really exciting. Okay,
Yeah.
great. I haven't seen that in my experience, but then again, I live in Tokyo, so I
Yeah.
haven't
You
been
have
out
to
of the
step out
country
from
that
the
much.
urban areas. Yeah.
Great, great. Okay. Well, I really appreciate you sharing that with a little bit about your business. Oh, hi Nick. Thanks for coming today. Thanks for joining us. Yeah. Um, well, is there anything else that we should know about these kinds of innovations, or even about your company right now, that you'd like to share with the community here?
Well, food security is always, biggest, concerns for the humankind, right? And we, as a Japanese, we never felt that, we someday we'll see, this food crisis. But actually, we faced in the last autumn, right? During the summertime and the September's, there were huge controversy about the, this, less supply of the rice, our staple food. And it really scares me, right? And I also had the similar situations in some years back. I was actually in Moscow working for some different business. And back then, because of political conflict, this economical sanction really sets in. And all of a sudden, any fresh food on the shelf of the supermarket was gone. And that experience really triggered me to move into this agri sectors. So we really need to combat these situations because the warfares, famines, it's everywhere nowadays. And how do we save this is our key interest here. And I should be everyone's interest.
Thank you very much, Aiki-san. That was really inspiring and also a lot of great information for us. Before we move on to the next speaker, who is Nick, I'd like to ask the audience, are there any questions you might have for Taiki-san here? Yes, would you like to go first? Could you stand up and give your name and also your...
Hello, I'm Kim. It's like a simple question. For about the autonomous drones, like there's birds that kind of might attack those drones. Like, are there anything special on those kind of drones that kind of keep those birds or eagles away from the drone?
That's a good question. How do you prevent wildlife attacks
Yeah.
against these drones that are tending to the fields? Do you have any answers
When
to
it
that?
comes to the drones, the agri drone is huge. It's like a 2 meter, 3 meter size, right? So usually the most birds are just scared away, so they never attack. And I personally never heard or seen such cases, incidents here. But it can happen. For instance, like a huge eagle can attack but I'm not sure. It's still not the case in Japan, but maybe it can happen somewhere. Also, the sounds of the drones, it's a multi-rotor drone. It's huge, so I'm not sure if it can happen. But if we're talking about the ground autonomous vehicles, maybe there could be some risk of hitting and colliding with some like animals or so. But still haven't seen it so far. Yeah.
Thank you. Good discussion here. I appreciate that. Did you have your question? Would you like to please go ahead, stand up, say your name?
This is interesting. So I have a question. So you said this is like a mega trend that you have like less and less people working in agriculture. It sounds quite scary if you have like in 10 years loss of 50% of the actual people working there.
Correct.
So
Yes.
that sounds really scary to me.
Yeah.
So I just wonder what's like I mean that basically means that in the future definitely we have a lot of automation there. So what's like in the moment the biggest obstacle for your company to have like a broad introduction of this kind of technology? Is it like legal issue, or do you have like culture issues? Is it just the money that's missing? What is in your mind like in the next 10 years, for example, the
Sure.
biggest obstacle you have to overcome?
Right. So I can list two main challenges here, right? The first one, the agriculture is a very traditional business, right? So the people there is also very traditional in mindset. So always many like a startup company, including us, are trying to offer some new things, but the acceptance is not so high up to now. Yeah, maybe in the next decade, probably the situation can be different. But this is the one biggest obstacle here. The second one is the agribusiness in the ground level is not so profitable nowadays. It is something different from our perception, but it's not really the profitable business as of today, which means they have no bandwidth for the additional investment. That's why this also delays this progress of the new technology applications. So to combat this, we probably need to have more government support. And it really can happen in many different countries. For instance, in France, you should see, or England, they are heavily subsidized by the government to assist their profitability, maintain the profitability. And because of that, they expand the yield and the productivity, and they're ready to export. For instance, grain export is one of the biggest business for France. And that's how the agriculture has to be supported by the government funding. But it's very tricky question. So
Thank you very much. Any final questions? Yes, please go ahead.
I watched Mobile Aloha Robot this year, January. And when do you think that such autonomously flexible robot, automation robot, product market release realize? When?
So if you see this Boston Dynamics robot, yeah, it's really fancy and interesting, and I'm sure they can really replace human labors, and it's also be very like agile and flexible to cover many small tasks, which is nowadays only done by the humans. But as I said, it's a matter of the investment scale, right? If it makes sense to invest and enjoy the returns, probably it can move on. So technology is right there, but the readiness of the acceptance or investment is still not here. And I personally do not have much answer to this question, but maybe in next some years, it can be 2 years, it can be 5 years. but it's all up to the market status. Yeah, because if people are ready to pay more for agri product, maybe it can be more profitable. Then they'll be encouraged to invest earlier. So that's only the point. The technology is there.
Thank you very much. Thank you all very much. Any final questions? Okay, well, I'd like to hand the mic over to Nick now. And Nick, I think that you wanted to give an update about your company that you're working with right now too. Would you mind introducing yourself and your company?
Sure. So I'm Nico. I work at Astroscale Japan, a subsidiary of Astroscale Holdings. So we're working on a project with JAXA for debris removal in orbit. So recently, actually this year, we launched a satellite into orbit to take imaging of the target that will be eventually taken down from orbit. It's a big piece of space junk. So I wanted to show some of the news that was released on the website. So I can only show what's in public already because of NDA stuff. So actually, very recently, we were given the contract to actually remove the debris that we're imaging. So this here is the first image taken by a commercial company of a debris in orbit. So other missions have done imaging or data collection, but typically they've been agency, so JAXA itself or NASA or ESA. And so this is a piece of debris that was left in orbit after launching its payload into a higher orbit, which is used like satellite communication satellite or maybe an imaging satellite. Maybe it relates a bit to agriculture because satellites are important for monitoring changes in landscape, changes in weather. I'm from Canada actually, and most of Canadian satellites are geoimaging, so they're monitoring how we use our land and how it changes over time. And it's very important for food security, even for urban planning, for example. So you see how the geography changes. So one of the important things is also to manage our orbital highways. So one of the growing topics right now is the presence of debris and the dangers it causes to in-service or new launch satellites. So the missions that are coming up now are related to removing debris. So now we've been given the second phase of the mission, which is to actually remove the orbit. And so this is the first image, but we didn't expect this, but JAXA actually released the images to the public. So this is actually the first time lapse taken, and this is where that image is taken from. Sorry, the controls are in the way here. How do I move this? I can't press play. The zoom controls are in front of the, there. Okay, so that's just a time lapse, and you can see it's like the first time we're capturing these images, and you're seeing us chasing the debris. So we're actually behind it, following, and you can see the reflections on the bottom there are actually the Earth. It's the Earth's light reflecting off the bottom surface of this satellite. And so this is quite novel, as no other commercial satellite has been able to autonomously approach an image. This is taken from about 50 meters away. And then we had a second part of this mission is to capture what's called fly around. So we then approach and fly around an image all around. We're collecting not just visible RGB data, but also depth. So there is 3D imaging happening here as well. And this was really incredible because this happened overnight. So a lot of us came in the morning and we knew it happened, but the information is not readily available. You have to download it from the satellite, so there's no direct connection. So for the most part, these satellites are robots. They're operating autonomously. Operation room has specific time slots to communicate with the satellites. So we have a chance to send commands, receive data. And yeah, here's kind of a nicer image that's blown up a bit, but we can see the condition is very good. And so it's confirmed that we'll be able to go and attempt to try and capture it once we prepare satellite and launch. So probably kind of end of 2026, I think, is what's announced. So these are all in the summer. So just different fly arounds. There are two fly arounds. And so just last week, I think, we ended the mission. So we'll be parking the satellite behind it, following for a bit, and then the satellite will deorbit itself. So it will push itself into a decaying orbit and fall and burn back into Earth. So the objective is to be able to do that to other debris, remove them from what we call low Earth orbit, LEO, and make room for other satellites like Starlink and OneWeb to fill the skies with, satellite direct-to-phone connections. There's some other companies that also work in similar space to identify and track these objects from Earth. So here's a company called HEO, and they have an image of our satellite and the debris. So this is taken from ground, and it's moving fast. So it does one lap around the Earth in about 90 minutes. So it's moving 20, relative to Earth, something like 20 kilometers per second, something like that. I might be wrong about the speed, but yeah, typically around that speed for low Earth orbit to not fall into and burn up. And this is in a stable orbit. If it's left there, maybe it'll be there for another 20, 30 years. It's already been up there for 15 years, about. So this is the latest news. So we were able to actually come within 15 meters of the satellite, the closest ever by commercial satellite. And then the system aborted itself. So it detected something that could possibly cause collision, and the safety measures kicked in and backed off. And that kind of signifies the end of the mission. We were trying to get actually within 1.5 meters, which would represent the spot where we would be to execute a capture procedure to grab the debris and then move it into a decaying orbit. So yeah, this is from our website. It's a press release from today, 2 days ago. And yeah, so this was all this year. It's several years of work, but yeah, it takes about 2 or 3 years to develop and build a satellite that will do something like this. Maybe to talk a bit more about what I do at Astroscale. So as a senior robotics engineer there, I'm looking at how we develop our robotic system, how we take our models for simulating this procedure and how do we deploy that onto the satellites. So not just the code, but the hardware as well. Yeah, any questions? Yes.
I beat her by a second. You said you had a contract to remove this. Who was that from?
So that's from JAXA. So JAXA put out the order for. Oh, JAXA is Japanese. It's a Japanese SpaceX. It's Japanese NASA. Yeah.
Ah, okay.
Yeah.
So
So it's governmental.
they contract. Can you disclose how much was that contract?
I don't remember off the top of my head, but if you just look it up in Google.
Oh, so you could actually Google that. So
Yeah, yeah, it's public information because it's governmental.
ah,
Yeah,
okay.
yeah.
So how many people are on your team that developed this?
So I only joined last year, so I wasn't really part of the phase one mission, which was basically to do data collection and imaging. But Astroscale Japan now is just over 200 people, I think. Yeah, we've recently passed 200 members. The engineering team is about 75% of that. Yeah.
Okay. Yeah, I got a million questions, but you guys are located here. Like, where are all these engineers? They remote or they're in a central
So,
office?
yeah, so our main office here is in Kinshicho. Most people come there. We have a clean room. We also have a demonstration facility called the Orbitarium. Actually, it's done for education, so we often have events there for usually for children, but I mean adults are totally welcome. It's about learning, right? It's about learning about space, about the issue that we're trying to tackle and trying to promote space sustainability. And yeah, I mean, everyone's welcome to visit. I think you need to reserve to visit, but yeah, it's available.
That team of around 200 people, was this the main project they've been working on, or are they working on various things?
That's been the main project for the past 3 years, as I understand it. And there's been other projects going on as well, but nothing that we can talk about. Yeah.
Wow, that's cool.
So yeah, you had a question?
Yeah, thank you so much. So I was wondering, I know you work on the robotics team, but
So interesting question. So actually this summer Astroscale IPO'd, so I guess we're not really a startup anymore. And globally we're a bit over 600 in 5 countries. So we no longer have the office in Singapore. Astroscale started in Singapore actually, and then they moved the holdings and opened Japan. And I guess to answer your question about how what's the challenge of working in Japan as a startup? Definitely as an engineering company, and so in my work experience, I've only worked in startups, and I can tell you one of the challenges is definitely getting the engineering talent. So when you're tackling something like a global challenge where the market and your target market is not just Japan based, you're bound to run into the situation where you're going to hire foreign engineers, for example, in a technology company, and there's language barriers for them, for me as well. And culturally, it's just a different working style. If you're stuck to the Japanese work culture, you're going to lose your engineers pretty quickly. I think maybe Tim knows a thing or two about that as well.
Because I work in recruiting.
Yeah. uh,
How do you select the trash you want to basically take down? Is there like
ah,
somebody, the highest bidder tells you, or and you just have
s-
like easy way to go up, or is it just
yeah.
more like risk based?
Interesting question. So in this case, we didn't select. There's a selection process that went on with JAXA, and they have their list of candidates. They know what assets and what junk they've left up in space. Typically, you don't go and touch another country's stuff.
Was this a Yaksa satellite?
Yeah, it's a Japanese. I guess you can call it a satellite, but it's actually unprepared, uh, inactive piece of debris. It's literally just a chunk of metal because it's a rocket stage, so it was used to propel only. But the selection process, they collect their information and data, and they may have certain candidates, and then there's process to do feasibility and analysis on how it would be captured, and then they may shortlist, I don't know, two or three, and they have a committee that'll make the decision.
Follow-up question. Do we have like some like next objects already in the plan?
Mm.
How many are there?
Yeah, so I can't answer that question. What I can say is that this project is commissioned by JAXA as a commercial demonstration. So they, on purpose, it's intentional to hire a commercial company to do it, to show that it can be done commercially, not just by JAXA or by NASA or ESA. And same thing is happening in other countries where the government organization is outsourcing to commercial companies who are building these technologies. So they're not building and selling to NASA, they're actually operating and building for themselves as a product or as a service.
So you don't plan to capture any other objects in the near future?
Can't answer that. Thanks. Yes, sir. So you mean like for one satellite, how many can it go and bring down? Uh, I mean, typically the limitation will be your fuel and maneuverability. If you're taking things from the same orbit, you might be able to do more since you're not raising or lowering. The one that costs more in fuel is raising since you need to accelerate. In our case, the contract is just for the one, so that's the mission. I'm not aware and not at liberty to say anything more about the content of the mission. Oh yeah. Yeah, yeah. There's from Earth actually the trackable size of debris is about 10 centimeters in diameter, so about this big. And I think right now there's recorded something like 100,000 debris that's tracked. There's a lot that's untracked, things that we can't see. Um, Actually, there were issues a few months ago. If anybody follows any space news, there's this Boeing Starliner that was, um, you know, connected to the ISS, and they were kind of trapped there. And at some point, the astronauts were asked to suit up and wait in their vessel because there was risk of debris colliding with the ISS. So that's a risk, and those are trackable degree. There's a million more smaller pieces that can't be tracked, and so one of the kind of agreed upon situations is to deorbit the bigger debris first, because they're the ones who create the smaller debris. And the smaller debris is way harder to capture. Mainly, I think, because it can't be tracked.
For you to identify what is the place that you can clean up.
Yeah.
It's kind of weird.
Yeah, you have to think about space as not similarly to how you would clean your home. Like you're not sweeping up a corner because your corner is
Oh, it's flat.
well, no, it's round.
Okay, yeah, no, the space is round, yeah.
Yeah, and so it's round. It's got height. It's got depth, and it's traveling relative to Earth at X kilometers per second. So we don't necessarily look at an area, but a volume, which is orbital altitudes. So right now our mission is in the LEO space, so low Earth orbit, typically 400 kilometers to 800 kilometers altitude from Earth. That's where most of our satellites, communication and observation satellites actually orbit. So that's actually where there's the most active traffic, and possibly where there's the most active, like trackable debris, since it's closer to us.
Would it be worth it to send a ship up there to collect a certain volume of debris?
Yeah.
This has to be determined, no?
Yeah. I mean, commercially, it's viable, especially since you have companies like SpaceX who are launching, 20 satellites every week or something like that. And so this this falls into a problem that was identified by actually some scientists at NASA in the 70s, I believe. Even back then, they already could identify what's called Kessler syndrome, which is like a catastrophic decay of debris. So debris hitting other debris, causing smaller debris. For example, there was a collision that happened earlier this year, I think, and one debris was hit by something small that was untracked, so they didn't know this was going to happen, and it created 2 or 3 thousand other debris that they could track. So there's still maybe thousands more smaller pieces that are now just flying bullets. So the idea behind removing your space junk is about sustainability. Similar to how we would do it on Earth, we clean up our garbage off the street, right? Maybe you'd remember during COVID what happened in Paris when the garbage collectors went on strike, and the streets of Paris were just flooded in garbage, traffic, right? Traffic, garbage, smell, rats. So similarly in space. So I'm not sure about space rats, but we'd have a lot of we'd have a lot of blocked roads.
Someone that sent
If there's any room coming up for that kind of stuff.
Yeah, so that's interesting you bring that up, and so that's part of the space sustainability work that Astroscale does as well. The U.S. branch does a lot of work in D.C. with the U.S. government, NASA, Space Force, and other lawmakers to start engaging them in writing into policy and regulation about regulation about the lifetime and the duration of missions, like satellite missions or satellite assets. And so recently there was a summit where many countries signed on to, forgetting the exact naming, but it's something to do with zero debris enactment for missions. So what you send up, you bring down. Yeah, so that's starting to come into play, not just in North America, but across Europe. I think the European Space Agency recently got on board with that as well, and UK as well. Yeah, sure.
We're almost out of time here, actually, so.
Yeah, sure. Yes, please.
Charlie, and
That's very, yeah, that's very interesting. So coming from logistics, I think when we look at the logistics industry in Asia versus Europe or North America, it's very much a different need. In Asia, especially, if you go to a logistics center, I would say if you go before COVID, you'd see 110% of the workers are human. Of course, there's conveyor belts and all that, but then you have humans taking off of conveyor belts. So it's very, very human labor intensive. So there was a need to develop a lot of logistics, robotics, automation technology. The and I think that's driven Asia to develop it faster in a sense or earlier. The US, I think, is catching up. The European companies that I've been following have kind of developed in a different way. I'm not going to name any names just because I don't want to get into that. But I'd say globally they're pretty even, and I think they've developed the technology based on their needs as a cultural labor market. Maybe it's difficult for like an Asian logistic company to enter the US market because the need is different, the cost is different, the warehouses are built differently, right? So that's kind of my view on the technology state of logistics, like globally. The reverse is not necessarily the same, though. Yeah. As for space, I think it's interesting because we have Astroscale kind of right now looking like a leader for like on-orbit services, especially now that we've proven we can approach inactive debris in orbit. We also see companies like iSpace who are working also with JAXA to send rovers to the moon. But they also have US branch, European branch. And then you have company that's really advanced in robotics like Gitai, who started in Japan and then moved to the US. I think one reason is to get into the NASA contracts, Space Force contracts. So in terms of global robotics for space, for sure Japan has pushed out a lot of technology. But it's interesting to see what comes out of Europe in terms of robotics. They've been known, especially Germany, have been known to be a leader in developing robotics, and their space development program there is actually very, very advanced. But yeah, maybe the mission level is a bit different. Can't say too much about it, and I'm not too aware about the entire European ecosystem.
Thank you.
Yeah, you're welcome.
I think we should wrap it up soon.
Yeah. So it's a pleasure to talk a bit about my work, a bit about Skill and robotics, and glad that you guys could all join us tonight. We still have a networking session after this in the open space, and they have the rocket pitches going on, I think. So join in if you can. Happy to connect with you guys and chat some more after this session. Any closing topics, Tim?
I think you covered everything very well. Thank you so much, Nicholas.
Okay, thanks,
Yeah.
guys.
And I'll see you outside the open networking area.
Yeah,
Thank you.
cheers.